If you've ever tracked a really high-value shipment, or even just a package that absolutely had to be there on time, you know that feeling.
Oh, yeah. That anxiety when the tracking link just stops updating.
Exactly. Now, imagine multiplying that stress by, I don't know, 10,000, and you've basically got the current state of global logistics. It's just so complex, so fragmented.
Incredibly vulnerable.
Yeah.
It really boils down to the classic data gap problem.
Mm-hmm.
You have physical goods moving,
Mm-hmm.
but the information about them,
Where is it?
well, who has it, what condition is it in, when will it actually arrive, all that is often stuck in these siloed proprietary systems. It's slow, or even worse, it can be manipulated. You just don't know the absolute truth.
So our mission today is to do a deep dive into the tech stack that promises to, well, completely eliminate that gap, to create something truly disruptive, hyper-transparent logistics.
We're talking about a really powerful convergence here. Digital twins, blockchain, and artificial intelligence.
Okay, let's unpack this a little. We're merging the virtual copy of a physical asset, that's the digital twin, with the immutable verifiable record, that's the blockchain, and it's all being fed by real-time sensor data, the IoT, and then optimized by AI.
And this convergence is, it's fueling a massive digital transformation. Just look at the scale. The digital twin market is expected to surge to over $35 billion by 2025.
Wow.
And this isn't just tech for tech's sake. It's driven by that whole Industry 4.0 imperative to secure and analyze data to cut costs and boost efficiency.
So the core mission for us today is figuring out how combining the DT, the virtual mirror, with the blockchain, the secure ledger, creates this sort of single source of truth.
A single source of truth that's essential for optimizing everything from a single truck fleet to, these massive global trade corridors.
Okay, let's start right there with that fundamental relationship. A digital twin is that real-time virtual model of a physical system, a truck, a warehouse, whatever.
You use it for monitoring, for simulation, for prediction. They're incredibly powerful tools.
But the sources we looked at point out a really crucial flaw when they operate on their own.
The flaw is simple. It's trust. If the DT is just running in a normal centralized system, you have no way to guarantee the absolute veracity of the data flowing into it.
Right, so if someone can alter the input data, how much can you actually trust the output?
Exactly. And that is precisely where blockchain comes in.
It's the technological guarantee.
It is. Blockchain provides that immutable, append-only decentralized storage. Once data is on there, it cannot be changed. This completely transforms the digital twin. It goes from being a mirror that might reflect a lie to a verifiable, reliable historical database.
So it ensures integrity, transparency, and
Yes.
you mentioned this term non-repudiation.
Yes.
Okay, for the listener, what does non-repudiation actually mean in, say, logistics terms?
It means you cannot deny that a specific event happened at a specific time. So if a sensor records that a refrigerated container's temperature dropped below freezing at 3 p.m., and that data is written to the blockchain
Instantly.
instantly, the carrier can't later claim it happened at a different time or that the reading was wrong. That digital record is completely ironclad.
You know, what's surprising then is that DT adoption is still pretty low in road transport and logistics.
It is, and the research suggests a big part of that is just the high cost, the processing and data validation cost of trying to run these huge complex systems in a traditional centralized IT setup.
Which really just highlights the opportunity here for decentralized open source blockchain solutions to come in.
Exactly. They deliver the trust without needing that immense centralized processing power that just cripples the traditional approach.
Let's move from theory to a really practical case study. Optimizing a vehicle fleet for a freight company using this exact architecture. This is where we get into the blueprint.
This is where it gets really interesting.
Yeah.
So this case study, it's all about making the assignment of drivers and trailers to trips more efficient and auditable. The whole architecture starts with collecting incredibly granular, real-time data.
Okay, so what exactly is feeding this digital twin? What's it looking at to make these recommendations?
It's looking at multiple detailed data streams. First, you have real-time GPS from the fleet, updating as often as every 10 seconds.
Okay.
Then you integrate that with information systems like a port community system, carrier databases with driver and vehicle availability, and even driver apps for reporting incidents or stops.
And the DT takes this flood of information and then processes it to make an intelligent assignment.
Yes, it's constantly running calculations, applying these sophisticated metrics KPIs inside what's called a rules engine.
Let's pause there. A rules engine. In simple terms, what's it doing?
Think of it as the ultimate automated logic checker. It takes the hard data, a vehicle's fuel consumption, a driver's remaining legal driving hours, kilometers traveled, and it applies a set of if-then company rules and goals.
So it spits out the most optimal driver-trailer pairing for a trip.
Right. And it dramatically cuts down the time a human manager needs to spend trying to figure all that out manually.
But the crucial layer here, the accountability, that comes from the blockchain. It's not recording every single GPS ping, right?
No, that would be insane. It's recording the high-value checkpoints. The research highlights 5 specific critical events that have to be registered on that ledger.
Okay, lay them out for us.
1.
Yeah.
The exact time stamp the transport order is received. 2. The digital twin's automated recommendation. 3, and this is so important, the final assignment decision made by the human user.
Wait, I want to jump in on that third point. Recording the human decision. If the DT recommends the absolute best assignment, but a human can override it, aren't you just embedding potential inefficiency back into the system?
That is a fantastic question, and it gets to the real-world nature of logistics. The blockchain guarantees auditable accountability, not perfect automation.
Ah, okay.
So if a manager overrides the DT, maybe they have some local knowledge the system doesn't, or for some other reason, that decision is recorded forever. Any deviation in performance can be traced directly back to that specific human action.
So it's not about blind automation, it's about making the human decision maker accountable. That makes so much more sense.
Exactly. And the last 2 events are 4, the formal completion of the transport order, and 5, the truck's time-stamped entry into a point of interest, like a port to load or unload.
So how is this all secured technically? Functionally, how do you guarantee the data going onto that ledger is clean?
So functionally, the system uses specific enterprise tools to manage that context data.
Right.
Then a dedicated software adapter formats and writes that validated info onto the ledger, which in this case was Ethereum-based.
It's security.
It's layered. It uses 2 distinct digital tokens. One token gets you authorized on the network itself, but then a second, separate token is required to actually write data to the blockchain.
So a breach on the general network can't compromise the immutable record.
Precisely.
Okay, the big question for anyone thinking of scaling this up, does the whole thing just melt down under real-world traffic?
The performance results were exceptional. They simulated really high workloads, up to 100,000 sensor updates per minute. And the system showed this incredible scalability, exceeding 1,000% of baseline performance. So it's robust enough for real-world use without collapsing. That puts the scalability question to rest.
That's very reassuring. So we've got the DT as the virtual structure, the blockchain for trust. But what provides the smart foresight? That takes us to AI and IoT.
Right, the Internet of Things, the sensors, they're the eyes and ears to the network. And they provide data that goes way beyond just location. We're talking temperature, humidity, shock, door openings, cargo weight distribution.
All in real time. And AI takes that massive verifiable data set and creates foresight from it. How does that actually translate into something a logistics pro can use?
Well, AI moves the industry from being reactive fixing problems after they happen to being predictive. It analyzes historical data along with external factors, traffic, weather, consumer demand, to predict disruptions before they even happen.
Give us a couple of examples of that from the source material.
A great one is from the cold chain. Dairy distributors in Saudi Arabia are using AI to forecast sudden consumption surges, like the huge demand spikes during Ramadan, weeks in advance.
So they can optimize inventory and routes way ahead of time.
And reduce waste, exactly. Another powerful one is at the biggest bottlenecks, the ports. AI systems can now forecast port congestion with up to 95% accuracy.
So operators can reroute ships or adjust container pickups before the traffic jam even starts.
It cuts container idling time significantly. It's a huge efficiency gain.
And this shift towards intelligent systems has fueled the incredible growth of digital freight platforms. The market is expected to jump from about $8.5 billion today to nearly $30 billion by 2033.
And these DFPs? They're the user interface for this whole stack. They connect shippers and carriers, automating booking, tracking, pricing, and they rely on that verifiable data from the DT and blockchain. Without it, there's no trust.
So for a listener who just needs to move cargo, what are the big names?
Well, for smaller businesses or quick bookings, you've got services like Uber Freight in the US and Europe, or Convoy, which really focuses on AI for route optimization in the US.
And for the huge global operations.
You're looking at platforms like Flexport, which is a full-service provider,
Yeah.
Customs, Analytics, The Works, or Freightos, which is more of a global marketplace for transparent international booking.
Now let's zoom out. We need to connect this tech stack to global infrastructure. This isn't just about one company's fleet.
No, this is about optimizing entire trade routes. And the Middle East and Gulf region in particular is just having a massive technology boom right now.
And that's being driven by policy.
It's driven by these ambitious national goals like Saudi Vision 2030 and the UAE's Net Zero 2050, but also by geopolitical necessity. The need for tamper-proof data is critical in a region with instability and huge trade volumes.
So how is blockchain being used there on the ground?
A fantastic example is the Saudi Food and Drug Authority. They use blockchain to verify pharmaceuticals and food safety. It gives them instant proof of origin and condition.
I see.
And there was a pilot program that tracked cargo from Dammam all the way to Rotterdam, synchronizing customs data at both ends.
And the result?
A huge reduction in clearance times and a lower risk of fraud, all because the data was mutually verifiable from the start.
We're seeing a similar fusion of digital and sustainability goals in major maritime hubs, too. The sources pointed to the new Singapore-Japan Green and Digital Shipping Corridor.
Yes, the GDSC. It's fascinating because it's tackling two massive problems at once. The green part is about building infrastructure for alternative fuels like ammonia and hydrogen.
And the digital part.
That's critical. It's implementing these advanced solutions to streamline port clearance and, really importantly, securely share information on maritime cybersecurity risks.
And hubs like Singapore are already using the digital twin tech we talked about earlier.
Oh, absolutely. They're using DTs to simulate peak season demand and to test out radical warehouse layout changes without ever having to shut down live operations.
So they can run what-if scenarios in a safe virtual space.
Exactly. And with the rollout of 5G, they have the ultra-fast, low-latency communication they need for real-time tracking of really high-value freight, keeping those DTs updated instantly.
So when we put it all together, what does this all mean? The narrative seems so clear. IoT gives you the visibility,
AI provides the predicted intelligence.
and blockchain ensures the trust and auditability for everyone involved. It's like the ultimate paper trail, but instead of paper, it's a diamond-hard digital record.
It means we're building intelligent, resilient supply chains that can react to disruption much, much faster than ever before. But, the path isn't perfectly smooth.
What are the big hurdles?
Well, standardizing the tech across such a fragmented global industry is a huge challenge. You have thousands of different actors with thousands of legacy systems. And crucially, we have to talk about the talent shortage. We need a workforce that's fluent in managing these new digital systems.
Which brings us to our final provocative thought for you to consider. The logistics industry is rapidly moving from manual reactive systems to these intelligent, autonomous ecosystems. We're talking self-driving vehicles, robotic systems, the works.
That's already happening.
So if real-time, verified intelligence is the most valuable asset in tomorrow's trade landscape, how do professionals who are currently operating in analog systems manage this change? What specific new skills like interpreting data from AI, managing exceptions, and keeping that human link accountable will be the most critical to learn to avoid being completely outpaced by this unstoppable digital revolution? It really is all about human capital adapting to this new world.